This lesson is about angles. In this lesson, you will learn how to use degrees, minutes, and seconds, how to find measures of coterminal angles, and how to analyze revolutions. Let's learn. This symbol means degrees. This symbol means minutes, which is part of a degree. And this symbol means seconds, which are parts of minutes. So 1 degree is equal to 60 minutes. 60 minutes equals 1 degree. It takes 60 minutes to have 1 whole degree. 1 whole minute is composed of 60 seconds. So if you want to know how many degrees, or how many seconds, are in 1 degree, you take 60 minutes and multiply by 60 seconds, and you get 1 degree equals 3,600 seconds. So for part A, we want to convert 74 degrees, 8 minutes, and 14 seconds to decimal degrees. So we have our 74 degrees. Then we're going to take our 8 minutes and divide by 60 to get the number of degrees. And we're going to take our 14 seconds and divide by 3,600 or 3,600 to get our number of degrees. So then we do the computation there, and 8 over 60 is 0.1333. 0.1333. And 14 divided by 3,600 is 0.0039. So then we just add it all together, and we get approximately 74.137 degrees. And that's approximately. And there you have converted degrees, minutes, and seconds to decimal degrees. So now for part B, we're going to take 34.817 degrees and change that into degrees, minutes, and seconds. So we take our 34 and chop that off. Then we take our 0.817 and multiply by 60. So in this case, we divided. Now we're multiplying. And we get 34 degrees plus 49.02 minutes. So then we need to take, sorry about that, little problem with the pen. All right, so we got 34 degrees, and then we have 49 minutes. And then we're going to take that 0.02 and multiply by 60 again, because right now we're in minutes, and we want to convert that 0.02 to seconds. So we have 34 degrees, 49 minutes, and then when we compute the 0.02 times 60, we get 1.2, and that's seconds. So that's 34 degrees, 49 minutes, and 1.2 seconds. Okay. Coterminal angles is when you have, here we go, when you have your initial side is on the x-axis, there's your y-axis, and then you have your terminal side. So here is the initial side, and this is called the terminal, because the terminal side changes. The initial side doesn't move. The terminal side is the one that's moving to give you that angle, that rotation that gives you the angle. So coterminal angles, suppose we have this angle measure, and let's say it's 52 degrees. A coterminal angle looks exactly the same as this angle right here, but it has a different measure. Suppose we started at the initial side and we did a full 360-degree rotation and then came back to the terminal side. What is the measure of that angle? Well, one full rotation was 360 degrees plus the 52 degrees that we continued going up. So the coterminal angle, or one coterminal angle in this case, is 412 degrees. So that is a coterminal angle. So next we're going to find the angles of smallest possible measure coterminal with the angle. So in this case we want to get a smaller measure, and so coterminal angles differ by 360, so we're going to subtract 360 and see what we get. So we get 8, 4, 5, well that's greater, 548 degrees, so that's greater than 360, so let's subtract another 360 and see what we get. All right, so that becomes 14, and that becomes a 4, so we get 188 degrees, and that is smaller than 360, so that is your answer for that problem. Now for part B, we have a negative angle measure, which means that instead of the terminal side moving counterclockwise, the terminal side has moved clockwise. So it has started on the x-axis and it has gone down. It has gone counterclockwise. So we want the coterminal angle with smallest possible measure. So instead of subtracting 360 degrees, because that's going to continue to give us a negative number, we're going to add 360 degrees. And sorry, my pen is a little messed up today. Okay, so when we add 360 degrees to that, we get 285 degrees. So the smallest possible coterminal angle of positive measure is 285 degrees for this one. All right, CAV, or constant angular velocity, CD players always spin at the same speed. Suppose a CV player makes 480 revolutions per minute. Through how many degrees will a point on the edge of a CD move in 2 seconds? So there's the center of our circle, and we construct the circle around it, remembering that a circle consists of all the points that are equidistant from the center, and then we have the point on the circle. Okay, so we want to figure out how many degrees, how much rotation this point is going to move in 2 seconds. Okay, so we know it's 480 revolutions per minute. So in 1 minute, this little dot is going to move 480 times all the way around in 1 minute. So we're going to use a basic conversion here. So we have 480 revolutions per 1 minute, okay? And we want to know how many degrees in 2 seconds. So we're going to convert this. Let's convert it to seconds first. So in 1 minute, there are 60 seconds, okay? So that's going to get our minutes to cancel. And then we want degrees in a revolution. Well, how many degrees are in 1 revolution? 360. So 360 degrees per 1 revolution. So that gets our revolutions to cancel. So we're left with degrees per second. And then it's just a matter of completing that multiplication process. So when we do that, an easy way, let's change color to make it a little bit easier to see. An easy way to do that is 60 goes into 360 6 times. So that makes that a little bit easier. And then we take our 6 and we multiply the 4,800 by 6. And we get, let's see, 0, 8, carry the 4, 8, 2. All right, so that's 2,880 degrees per 1 second, but we want 2 seconds. So we're just going to multiply that number by 2, and we get 5,760 degrees per second. Again, I apologize, my pen is having some issues here, but hopefully you can read that. That's 5,760 degrees per second. And those are the basics of the angles that we're going to talk about in class.